Michelle Brechtelsbauer is the Chief Strategy Officer of Last Energy. Michelle, what is Last Energy doing?
Hi, everyone. My name is Michelle Brechtelsbauer. I work with Last Energy. We are a modular nuclear development company. So we build really, really small nuclear power plants to help industry decarbonize. We have a pretty unique business model in this space because our units are so small. We've essentially productized and standardized nuclear power. So instead of building, stick-built plants that are custom for every single project, we're moving towards factory fabrication and true scalability through modularization through our technology. And then we're offering power to our customers who are industrial energy users through power purchase agreements. So we're taking the business model that you've seen pioneered by the renewables sector, bringing that to the nuclear industry so that we can truly scale up nuclear power where it's needed most, which is not just the grid. It's distributed around the world for small communities, for industry, and really truly trying to kind of bring this into the private sector hands and let the private sector lead on nuclear energy, including through private financing as well. But I'm really excited to be here at COP. This is Last Energy's first time joining COP. Our mission was actually founded first on climate change, and we've expanded that to ensuring that, all of humanity can flourish through clean energy.
Michelle, small modular reactors are the innovative game changer, if you will, the new technology that everyone's been talking about the last number of years. Can you give us a few more words on how they differ from traditional things, like what Westinghouse has done throughout its wonderful history and storied past? What is your company doing in this regard so different and so innovative?
Last Energy, we consider ourselves micro at nuclear power plants. So we built a 20 megawatt power plant that we do use the standard reactor technology, proven reactor technology, pressurized water reactor. But what we're able to do at that micro scale is look at the rest of the balance of plant and focus on innovation there that allows us to actually build these much quicker and focus on the real true problems that we've seen historically with nuclear project development, which are cost and schedule. So if we can standardize the power plant in its entirety so that it can be factory fabricated, manufactured in a controlled environment, and then the same thing built every single time, that's really the path that we see as being the most critical to addressing those issues of cost overruns that we see with most large projects, as well as the time it takes to build them. So as I said, we're at the 20 megawatt scale. There are SMRs, the traditional kind of buzzword in this space, small modular reactors. I think can speak more to it, but these are traditionally up to maybe 100 to 300 megawatts as well. And then of course the large reactors, the gigawatt scale ones that we see, really primarily supplying electricity to the grid and helping decarbonize grids of a lot of the major nations that have really committed to decarbonization.
I worked from the very beginning with the UAE on its 123 agreement and its nuclear program here with ENIC and the Westinghouse technology, the South Korean technology. What's different from a safety standpoint? Are these smaller reactors easier to secure and make safe? Or is it the same things that we have to worry about with the big reactors?
It is very different. At the smaller scale, you can do things that you wouldn't be able to do in terms of design at the large scale, right? So you have obviously a smaller source term, you have less fuel in the reactor, but it's also physically smaller. So you can encase it with more safety materials. In our design, we bury our reactor underground. You can do things like that you wouldn't be able to do with the much, much larger power plants. And then, of course, in terms of security footprint as well, there is a reduction there given the smaller source term. But I think the main thing is there's really a benefit to the environmental footprint of micro reactors as well as small modular reactors. And that's not just in terms of the physical space, right? So if we're working on integrating a micro reactor for an industrial customer next to their facility, we can actually build a private wire to their facility because we use air cooling in our plant. So we actually don't have to be near a body of water. And that's really critical for our customers because it also enables them to have those cost savings of taking out that grid connection, which is often can save them up to 50% sometimes, depending on the country where we're located. So those are critical things. But then even in terms of the regulatory timelines, right? Smaller footprint means lighter regulatory reviews from the environmental permitting perspective and all of those areas. So we're taking that into account through the design.
Michelle, I asked you before we started a little bit about an SMR powering a city. But talk to us about the challenges and the opportunities of integrating the SMR directly into a manufacturing, into a company's operations, just for those purposes, just for their needs.
First and foremost, I like how you frame it into a company's operations because that's what our customers care about is them, their operations not being interrupted and having that secure, reliable, consistent baseload power source that they need, and not having to change their business model in order to get that, right? A pulp and paper manufacturer does not want to operate a power plant. They just want to create their products. And so that's really the key thing I think that the nuclear industry and that Last Energy can provide those customers is the assurance that they're going to have the power that they need and they can just get on with it.
So they won't run the plant.
No.
You will.
Yes.
But it'll be right there, very close to them, and you will be part of their daily operation.
Yeah, one of the biggest pain points that we've seen, especially in the United Kingdom, is the time frame that it takes to get a grid connection. We're speaking to customers who are looking at, 2035, 2036 before they're even able to get grid connections. They're so constrained and, saying we need it now. I mean, really, they truly do. In order for them to not only work on their current operations, but have future growth plans, they have to have these sources of power. So we can build our facilities right next to theirs, do a private wire directly for electricity. We can also provide them heat on their campuses. And then critically, our power plants are 20 megawatts, but we can scale up to meet the demand that they have along with their growth trajectories, right? So if we're working with a customer who right now needs 100 megawatts, we'll build 5 of our power plants, and then as they need additional power, we can just build redundant capacity in a row right there.
If we're at COP33 5 years from now, what are we going to be talking about? What are the issues going to be? What are the highlights going to be? What are the new developments going to be? Just from your perspective, Michelle.
Right now, we have 52 power plants in our pipeline across the 4 countries where Last Energy is operating: the United Kingdom, Poland, Romania, and the Netherlands. So in 5 years, I certainly expect we'll have a few of those first ones coming online. We're looking at 2026, most likely, for the United Kingdom. So, at that point, we're going to be moving from first-of-a-kind projects to really transitioning not only our business, but our kind of overall global footprint to that high-throughput manufacturing model that I described. Of course, our first projects will be more bespoke. We get figuring things out, but by 5 years from now, that's when we're really going to start ramping up in terms of that scalability.
Any new or innovative technologies that you might want to highlight, you think we'll be seeing 5 years from now?
I mean, I think, at that time, Last Energy hopefully will have been able to prove that you can build a nuclear power plant for less than $100 million using only private finance and no government subsidy whatsoever.
That's fantastic. And in this part of the world, they have a saying, it's called Inshallah, meaning God willing, all of this is going to happen. So ladies and gentlemen, please, a warm round of applause for our panelists here today, and a really exciting topic.